I work on young stars and the planets around them outside of the solar system. What I'm really interested in is the origin of life on Earth and whether life might originate on an exoplanet. So that's a planet outside of the solar system orbiting another star. And that's a key goal in modern astrophysics, the search for life beyond the solar system. So the type I'm looking at, young stars and young exoplanets. And so a type of radiation, like X-rays sort of, and how much of that radiation do young exoplanets get, which affect the ability of life to form and survive on those exoplanets. I think understanding the origin of life on Earth and whether it might arise elsewhere in the universe is just a really interesting question. It's a very hot topic and there's an awful lot of interest in it, and a lot of the future missions are going to be trying to find life on an exoplanet outside of the solar system. I think it would be quite lonely if we're the only life in the universe, so I really hope we find life on another exoplanet, and it just helps us understand whether nature is different in different exoplanets. What I'm working on at the moment that is particularly exciting is that I'm a member of the James Webb Space Telescope Mid-Infrared Disk Survey, which is looking at about 80 to 100 planet-forming disks around young stars. And we have found water in the inner region of this disk for PDS 70. So it has 2 known exoplanets orbiting it already. And it's really exciting to discover water in this region because it's where Earth-like planets form. And understanding when water is delivered to a planet is, of key importance to understand the origin of life and whether it could occur on a planet around another star like PDS 70. There's nothing particularly typical about being an astronomer, so my days are always very varied. I travel a lot for conferences or to visit collaborators, but when I'm in Dublin, first I check all the updates for the day, all the new papers, so that's where you find out what's happening in the astronomy world. Then I would probably spend most of my day at my desk, either on online meetings or just doing my research on my computer. My actual research involves numerical simulations, so that's just computer modeling. So it's a lot of maths and physics and running code on a computer or on a remote server to try and find out the answer to a maths question. The best thing about my job is being able to work with just the freedom. You can work with pretty much anyone around the world. If you have a good idea and you contact someone, everyone is really friendly and very enthusiastic. People just want the science done. But the worst thing is probably that given that I travel so much, it's difficult then to have a routine when I get home. And so that's something that I miss. When I was in secondary school, I really loved maths and physics. I really loved the images from the Hubble Space Telescope. And so I always had hoped that I could somehow do them together. So I studied physics in university, but then I heard a seminar by an astrophysicist from the University of St. Andrews. And I realized then that I could, how I could bring the maths and physics and the astronomy together. So then I did a PhD actually in the Dublin Institute for Advanced Studies on these planet-forming disks, and I've just been in research ever since. My advice to a young person, if you'd like to get into astronomy, is to, I suppose, find what you're great at, because it's a really diverse job. You could focus on the maths or the physics or computer coding, and just stay curious and ask questions. There are never any stupid questions, and it's just one of those jobs where you're constantly learning new stuff. So if you just are enthusiastic and keep at it, then I think you'll do great.